Hey all, today we are going to determine the deduction of the world famous equation E is equal to mc square. Okay, let's get into the video. So as we all know that work done is equal to energy. So differentiation of work equal to differentiation of energy, and work done is nothing but force into distance. So TW equal to force into distance. So instead of TW we can substitute DE equal to force into distance. So then force is nothing but a rate of change of momentum. So DE equal to dP by dt, rate of change of momentum and distance. So as we all know, momentum is equal to mass into velocity. So differentiation of this P is equal to, applying UV method, we get mass into velocity and V into dm. So substituting this dp part in here, we can get dE equal to mdv plus vdm by dt into dx. Okay, so here we can see that dx by dt equal to velocity, that is changes displacement. So mdv plus vdm into, again as we all know, v equal to dx by dt, velocity, this relation. So instead of that we can substitute this term as v. So finally we get t equal to mv dv plus v square dm. So let it be the first equation. So here we are going to derive the second part of this equation, so which is nothing but the relativistic mass concept. The equation for the relativistic mass was already deduced, which is equal to m equal to m naught by root over 1 minus v square by c square. So okay, we are just rewriting this term as m equal to m naught. We are going taking this term to upper side, so we're getting power minus 1 by 2. Then m, we are just differentiating this term with respect to v. dv equal to m naught remains constant, this power comes here 1 by 2 into 1 minus v square by c square power minus 3 by 2, and differentiating the inner part of this bracket we get minus 2v by c square, as c square is a constant, so we just deduce this. So on rearranging we get dv equal to m naught, this minus minus cancels and 2 also cancels, so we can just simply write 1 minus v square by c square power minus 3 by 2 into v by c square. So okay, next what we are going to do is just we are going to split this term into 1 minus v square by c square power minus 1 into 1 minus v square by c square power minus 1 by 2 into v by c square. As we can able to see that we are just simply adding these powers, we will get the same term as the above equation. So we are just splitting this term into two parts, and so here we can able to see that on rearranging this into, just bringing this term here, 1 minus v square by c square power minus 1 by 2 into, just writing this 1 v square by c square power minus 1 into v by c square dm equal to dv. So this part is nothing but that is m. As we can able to see, this part is, instead of this part we can just simply substitute this part is equal to m into, just cross multiplying, I'm getting c square minus v square by c square power minus 1 into v by c square. So next dm by dv equal to, just bringing this m v, and just they will become reciprocal c square minus v square into 1 by c square. We can just simply cancel out these two terms. So finally what we are getting here is dm by dv equal to mv by c square minus v square. So okay, what we have got is dm by dv equal to mv by c square minus v square. So just cross multiplying c square dm minus v square dm equal to mv dv. So and bringing these terms that side, mv dv plus v square dm. This is our second equation. So what is the first equation we got? Already we derived dE equal to mv dv plus v square dm. This is our first equation. As we can able to see that the right side part of these equations were both were same, so we can just simply equate these left side parts. So just nothing but d equal to c square dm. On integrating these both the sides, we can just write d equal to c square is a constant, dm we can get e equal to c square m, which is nothing but e equal to mc square.